Recording so we can get started while people are joining in, I think. Okay. Good morning, everyone, for this distinguished webinar series in AI and cybersecurity. Today's speaker is Dr. Ram Dantu, Professor, Department of Computer Science and Engineering, University of North Texas. The title for today's talk is, Can an Average Joe Secure Your Network? Dr. Ram has more than 15 years of industrial experience in the networking industry. He has worked for companies like Cisco, Nortel, Alcatel, and Fujitsu Networks, where he was responsible for advanced technology products for concept to delivery. Dr. Ram is a professor in the Department of Computer Science and Engineering at UNT. He is also the founding director for Center for Information Computer Security. He has received several NSF awards in collaboration with institutions such as Columbia, Purdue, University of California, Davis, Texas A&M, and MIT. During 2020 to 2022, he received 6 NSA awards in cybersecurity, totaling $2.5 million. Dr. Dantu has contributed to the field of cybersecurity, focusing on areas such as safe transportation using mobile networking, telemedicine, telecommunication protocols, voice over IP security, mobile social networks, 911 emergency dispatch protocols, and security informatics. Recently, he received the Best Research Paper of the Decade from IEEE Transactions on Intelligent Transportation Systems and Best Paper Award in BCCA '2023 and TPS '2023. Dr. Dantu is an author of 20 patents, most of which are deployed in the industry. He has been recognized through various industry awards, which including being named as a finalist for Tech Titans Award and receiving a D Magazine CIO/CTO award. Furthermore, he has led cybersecurity efforts in Dallas-Fort Worth area, earning recognition as one of the DCEO's Dallas 500 for dedication to technology and cybersecurity. Dr. Ram, that's quite a lot of experience and mouthful of things. We're so honored to have you here, and thank you so much for spending your time this morning as part of this webinar at UND. The floor is yours to share your presentation.
Thank you. Thank you. Can I see my presentation?
No, I cannot see your screen yet.
Okay. Shall I have to share again, I guess, right? Yeah.
Yes, please. Yes, we can see. Yeah, see the screen. Yeah.
Good. I will go in this mode. Okay, great. Can you hear me well?
Yes.
Okay, perfect. As Prakash introduced me, thank you very much for giving the opportunity to meet all the universities and the participants and everyone. My journey started from actually in India, from Madras, kind of special, a little bit different than most of the people. I actually started my bachelor's called BTech there. Anyway, so after that, completing my bachelor's, I went to industry, worked for some time, and came back and did my master's, and went back to the industry, worked for some time, 3-4 years, came back to the university to do my MTech. Then I went back, this is called Madras Institute of Technology. Then went back to the industry, worked for some time, came back and did PhD in Canada, and then started working back to the industry for about 15-20 years. Then I came back to the university. Now, I'm also working with several industries here. I also have a small company I'm trying to propagate, not related to security, but about AI and more on the telemedicine. Anyway, so this is my kind of background, and now we'll start with this. Is that we'll start to go with the introduction, why we started this problem at all. We collected the data and how we want to empower the communities. Then we actually describe how we started working on this initially without the large language models. That was a little bit tough, but we started working on it. We built the architecture and started testing. And then we found a lot of research challenges, especially in the natural language processing, NLM. And I'm not an expert on NLP, but I started a little bit understanding it. Then suddenly we got into this LLM last 2-3 years. And when also we started working on the ontologies, how we can actually look at the worldviews, how everyone look at the world. So we converted it to ontologies, and then how we also worked on how to merge and match the ontologies so that they can be used by the large language models. And then I will also describe the research challenges that we have in all these things, what we have started the journey. So then we'll have conclusion and some research projects in our lab. So my real passion is how can we empower citizens, involve them in our cyber, very complex systems, because every time we see the cyber, the people use it. It's very complex. And how can citizens involve? Is it only the system admin? What about the citizens who are actually using it? How can we actually take their feedback? And also, these security configurations have to be changed dynamically. How can the citizens can also help in this? So basically, we want to see security for AI, AI for security. How can citizens contribute to both of it? This is the project we started. How did we start this project initially is that I was actually explaining this to our local congressman, Pete Sessions. Then he was very impressed on some other work we are doing, and he said, Ram, I think we should think about how do we involve citizens in this. Then I kept on thinking. Then I went to some other opportunity in Attorney General Jeff Sessions. Jeff also was actually asking the same thing because he's an Attorney General and he was very successful in implementing. He was also senator, I think, for many years. He was very successful in implementing a neighborhood watch. So what is the neighborhood watch does is that it is actually the people come together, work together, and they help the law enforcement and watching their neighborhood. This is basically for crime prevention through the citizen involvement. This has been there and successfully deployed. As you know, a lot of communities, it's already there. And now the Homeland Security, it's part of the actual Homeland Security at the neighborhood level. That's what you can think about it. So different people call this differently. Some people say crime watch, some people say block watch, and some people say business watch. Even business, you have to watch the neighborhood house. So how can we kind of do the same thing? Now, our neighborhood is not only just the physical neighborhood, now we have cyber. We have cyber neighborhood. How can we actually do this? So what is the cyber neighborhood? Or that's what we need to first understand. Or the family and friends in the house who are physically around you, they don't know much about IT, but they are your neighborhood, yes. Wi-Fi users around you, wherever you go, computers around you, Bluetooth users around you, are they neighborhood? Yes. Friends who have a cell phone, they're using 5G, 4G, whatever it is, are they your neighbors? Yes. You go to the hotel guests, of course. The cars you are driving on the road, the people moving around, are they your neighbors? Yes. IP addresses around your address, the IP address, answer is yes. Open or encrypted or hidden, doesn't matter. Any of these things still, yeah, they're still neighbors, whether they're hidden or not hidden. If you are in the cloud, there are a lot of microservices are happening. Are they actually neighbors? Yes. So who are the neighbors? Who would say it is all the above? What is happening? It is kind of neighborhood changing from one place to another place. When you get up in the morning, as you go through one place to another place. So that is what is happening. Now, you have gone to the hotel and stayed, some of you, most of you almost, I think. Who knows the best in a hotel? What is happening in the rooms? If there are any drugs, if there are anything else is going on in rooms, who knows the best? Is it the owner of the hotel? No. Is it who knows the best? So I'm not sure who is in the audience, but if they can tell. Who knows the best? The people who knows the best are house cleaning and maybe kind of called janitors and other people working there around. Those are the people understand the best what is going on in the rooms in a hotel, motel, or wherever it is. And now we want to empower them. We want to make them contribute to the security around us. The best way is to understand what they're saying. Whenever I say average Joe security network, people come back, and we actually publish papers in this and ask me, hey, how can you teach them? You can't teach the average Joe security. No, it's difficult. I'm saying, no, we don't want to teach them. We want to learn from them. That's what is required. So how can they help us? They patrol my cyber neighborhood. Any suspicious activity, they can help us. So basically, if you see something, say something. If there is a disturbance, if there is a perturbed disturbance or some instance, please tell us what's going on. Again, you don't need to know anything about IT or anything about the technology. Just speak plain English or sometimes your own language. That's fine. But there are a lot of noise. Whatever the different people are there, they see the world differently. Then you have a lot of duplicates and overlapping information and also sometimes nonsense. And we don't understand, or they don't understand. That's fine. This is life. This is how the ground truth exists. Then it's our job to understand it, not their job to convert it. How can we make sense of it? Different people inform differently. The worldviews are different, and those are changing. So that's a good, bad, or actually it's an asset. Sure. So we should let everyone and everything around us, not just the people moving, people not moving, or the actual things not moving also can help us. We call them Internet of Things. Anything that's there, then may be able to, on the internet, can be able to help us. This is the big puzzle. And the more importantly, I think people have not noticed is that as we move around, the neighborhood moves around with us. That means the environment is moving with us. How can you do a handoff between one neighborhood and another neighborhood so that the neighborhood is secure for us, for the people around us? Now, so basically the methodology here is that we want to first try how the citizens can help us without a language model, which is right now a lot of people trying to use it. That's the first thing we did. And I would like to kind of share with you what first thing we did is that we actually, before we actually started developing anything, thinking, first, let's understand what are they actually interested in. We actually asked the people in the Starbucks, people asked in the motels, we visited them, and in the front desk of so many health clinics and so many different places. These people are sitting there either as a patient or as a just user of drinking coffee or something else. And of course, the workers in the Starbucks, that they're more important for us because they watch these people continuously from the morning to evening. And ask them, hey, if you want to tell something not going well or something to inform us, what are the things that we are seeing? Then they'll tell us, you say, majority of them in Starbucks and other places, they say it's a sexual content people are watching or something that they're Googling or doing something, terror or crime, some drugs, weapons, or talking about it, social media, gambling. So these are all the percentage of people. So what it means is that, as you see here, that is the kind of command or thing they are going to inform us. Hey, there is something like this is happening. There is something that people are kind of seeing something about weapons, or people are gambling, or something like that. So that is what they can see. That is what they can inform us. So how can that be converted into some rules and something that we can use them in our routers and switches and firewalls and IDSs and IPS and all those things. So that's what is interesting. So the next one is that how are you going to tell, and what do you want to do with the unwanted users? We don't want some people to use it. They say, okay, block them or put a password, username. So these are the commands they can give us, or they can talk. They can actually speak in the voice, not necessarily type. That's enough. Take a phone and just talk about it. And we should be able to understand. And a lot of times we see a useless response. Okay, it's a useless response. So that maybe we were to ignore, depends on whatever response they give us. The next one we did is the important, very important thing is the voice over IP calls. So I did a lot of research in this area, voice over IP security, spam detection in voice over IP. And we have actually kind of measured what is a nuisance level of a voice over IP call. And we also said using AI, it's almost like 12 or 15 years, 20 years ago, that one student did a project with me saying, how can you actually figure out who is going to call you next? How can you figure out whom are you going to call next? Also, how can you figure out if you call somebody, that person is going to lift the phone or take your call? So these are the important questions every day we actually face in our life. But anyway, coming back to this, when you ask the users, they are sitting there on asking, say, if I say unwanted call, I call more than spam, I say unwanted call. And then they say, block the call. These are the commands they give, or send it to the voicemail, or just kind of disable Skype altogether. I don't need a Skype. And there are also some kind of people said useless, something useless information. Next one, we went to, again, these are all the places where we collected our data. That's how we started our journey. And we have collected more than 1,000 of these people's responses. and put them in our database so that we can test what we're doing. And when a stranger is attempting to access their home network, what do you want to do? There is a Wi-Fi. They'll say, again, these people don't understand how to configure Wi-Fi. They think, hey, I know I can get onto internet using a Wi-Fi because they actually use password and all. Then they say, hide Wi-Fi for them. Or increase the security strength, or change their credentials, like changing a password or something, or put something or some other security equipment. I don't know what it is, but just put it. So add it. So these are the commands they gave us. Some are the people trying to enter your computer or your system. What do you want to do? Some people said, hack them. Okay, that's kind of understandable. Then you need to have some remote access, login credentials. Then they'll tell, hey, unauthorized attempt. These are all the commands. They will tell us, hey, also there's a breach. So the next thing we wanted to, we collected information is about if there is physical or network-based danger, what do you want to do? Maybe there should be an alert system if some car is parked opposite to my house. I was not there. Or somebody's knocking the door. I was not there. So we can actually put scanners, cameras, and collect the data. So that's what this question is. They said, okay, just go ahead and put some external solution. Somebody says, no, not required. Just the bell is enough. In the doorbell is enough. And somebody said, don't worry, I don't want any of this. But let things happen. And there are a lot of useless responses as far as this is concerned. It's interesting to see that. Then we keep on going. There is also a very important thing is abnormal electricity usage, especially we ask them in the apartments. And there are a lot of people living in the apartments using the crypto and mining it and using a lot of electricity because electricity is free. What are you going to do? Collect more information about them, why they're using, limit them. Same thing we asked of all of these people, the age is, you can see, and the age is between, anywhere from 20 to 60, 69, also 70 years also there. So surprisingly, there are more people at the early stage and also the late stage because they're all retired kind of thing. The job categories, they all work in different service industry. As you can see, they're all white collars. They are not computer science professionals or IT professionals. The people who are all there, almost equally divided between male and female. Now what we did is that I will try to actually try to quickly go through some of the implementation. We did it 3 years ago before the large language models, LLMs, came up into the picture. So we did some semantic analysis, translate and install. My background is bit more on networking and systems. So we actually implemented it using OpenStack. So there's a lot of VMs we created. And then we started use all these 1,000 people, responses they gave us, collected all those responses and started feeding those responses to the NLP engine and see how it is going to interpret, translate, and also install in the routers or firewalls or IDS and IPSs. That's what the results quickly. I'm not going to talk too much about this because it's boring for you because it's kind of mundane technology, which a lot of times you guys use it. But I will talk about after implementing this, what are our challenges we found out. So basically, there's a grammar engine, there's a semantic engine, So we have the different interfaces in the OpenStack, that is the private cloud system, which we built it. I'm sure a lot of people are using this. And next is the cloud environment. What are the different kind of nodes here, a controller, a client, of course, network security functions are there, NSF we call. By the way, there is a group called I2NSF. That is, NSF stands for Network Security Function here. There's a working group in IETF. This is Internet Engineering Task Force. They were actually looking, how do we actually bring in the users' security on the cloud, but when the users kind of pick a particular security function. So this is just mundane. All of you know the action, when, from, to. These are all, how can we convert the human language into action, when, from, to, all those things. We tried to do this. There was no LLM at the time, 2021. This is where the NSA was interested in this. Then, for example, alert when ping from PC1 to PC2, or block SSH. Those are the commands. Sometimes they are grammatically correct, sometimes they're grammatically not correct, but nevertheless, it's the semantic analysis that's going to actually block it. By the way, if you have any questions, you can ask me in the middle. There's no problem. I know my time is limited, but we'll see how it works. There are IDS rules, then they will be converted to IDS rules or IPS rules or the firewall rules. As you can see here, block Raja PC from accessing so-and-so Facebook, and don't log in Juniper firewall. So all these things are converted from somebody saying, hey, block Raja's PC. So that's what is kind of thing which we kind of used it. And I think I will quickly go through. This is all of you is boring because all of you know how this works. And I think I would like to go block all websites to my network. These are examples from 9 a.m. to 4 p.m. Or allow internet to Raja's PC, deny, or block Facebook for my child from night 11 o'clock to the morning 6 o'clock, something, whatever the rules you want to give. So we actually started testing the performance of this particular system. This is kind of the research is more on the semantic analysis and also some of the performance and other things. And we started actually with the Amazon as a cloud to do that, but we're not, it's actually too expensive at that time, and they're charging too much. And we stopped it after 2 or 3 months. Then we started developing kind of private cloud ourselves using OpenStack. That's what's happening. So we have examples, which I told you, we collected more than 1,000 samples from so many people. And they are all people who don't understand much about IT or computer science, different kind of background people. So our target is, what is the accuracy? What is the precision? What is the recall? So again, we don't want to talk too much about this because you're all expert in this. You understand the AI and other things. So you can see that the precision or recall, they're all almost like 95%. And there is also you can see that as far as recall is concerned, semantics, it actually varies very largely. I think this is because most likely, I think the people they gave whatever the commands they gave, whatever the comments they have, I think sometimes they don't match semantically to our engine which we implemented, which makes sense. So that's what you can see. I had around 400 kind of those responses. Sometimes goes up, sometimes goes down. That's what has happened. Same thing with of course, we can calculate F1 score. We see that it's pretty good in understanding this. Policies for following grammar, around 680 of them. Some of them are not following. So I think it all depends on the score, whether they're following what we know is correct, what we know, then we can compare with that. So that's what was happening. As you can see, the score for with respect to different users, a good knowledge. Still, they are even minimum knowledge people are able to get almost like 70%. People who have good knowledge, obviously, they can speak more correctly, and people who don't have minimum knowledge or no knowledge, they will speak whatever they want to do, say that. That will not match the semantics what we have. And so there are also how these are matching against different IP, different kind of firewalls and Cisco firewalls or IP tables or SNOT, whatever it is. So again, this is kind of some IDS rule generated. It is standard. There is some kind of matching. You have to match that, and you can fit it according to the standard route what we have. Again, the fit it means you got to fit it according to the device which you are thinking about. This device can be a Cisco firewall, a Juniper, or Palo Alto, whatever it is, but you have to match it. Any device, whatever you are using it. Same thing with access control or other devices as well. You can see here, and there's almost like 80% good acceptance one. Some of them are rejected. So this is general. So the base rules will not change ultimate result. That's kind of a redundant base. So these are all, there are some duplicate rules are coming. Then there are some conflicting rules are coming. There are some overlapping rules are coming. So these are all the challenges which we'll see. What are the challenges we found out? We found out that we have to hand off environments when humans are moving. We have to do the handoff of this neighborhood, or you can call between humans also. So I have to give it to the next guy. Hey, I am driving on the highway, and I find these 3 places debris. Hey, watch out. So I can actually give that information to my next guy who is traveling on the road, for example. So like that. So it's going to be a different paradigm. We are entering a different paradigm. You remember when you are actually doing a 3G, 2G, and I'm pretty old guy, so I was using also 2G when they started. Then it went to 3G. So there was a big problem to hand off between when I'm actually in my house and get out, and then on the road, then my call gets dropped because it's kind of a different environment. So that's handoff was not happening. Same thing is going to happen here. So this is a paradigm change for us. So this paradigm, we have to handle this. There is also a semantic analysis to how do we convert the semantic analysis to the predicate calculus for security device. Why? Because different security devices expect different way. Cisco, what he expects is different from Juniper, different Palo Alto. And in fact, the IETF, the Internet Engineering Task Force, they're the one who define all these protocols, including TCP, CTP, whatever you name a protocol in network, they're the one. They actually, even 20 years ago, because I was going there and I was in the industry, and they started coming up with drafts to put standards on how the IDS rules look like across. No, it didn't work out. Nobody wants to share IDS rules or IDS how they do it to the other vendor. No. So that was so that's a problem. That's how you convert. So what we have to do is that we have to create intermediate predicate calculus engine, intermediate engine that is independent of the vendor. what we find out that it is very important, it's a challenge. How are you going to actually, from the semantic analysis, it fails, then you have to inform, give the feedback to the human. Hey, correct, it's not correct. So can you say this sometimes again, or can you say it differently? Or are you saying this? That's what kind of input you have to tell them. Then they will tell something. So there is a feedback loop going back and forth. There's also from intermediate rules, they may not, that engine may not understand it. Again, that has to be, we have to feedback to the semantic analysis, and that goes to, again, to the human problem. And again, when there is a vendor, that is a Cisco or Palo Alto or whatever it is, if that doesn't fit in there, then we can get feedback and then try to adjust, revise the command or the rule which we have created to that particular vendor. So these are all challenges which we have to do it. And it's not as simple, trivial, but I think it requires a lot of, I'm going to talk about it, how we're going to handle those kind of challenges soon. So this is the next point in this, is that ontology merging. So how are you going to kind of describe the world? Whatever you describe, it has to match the kind of thing which the semantic engine is expecting, or the LLM now is expecting. So that is the challenge. How are you going to feed it? We can feed few shots, few examples to the LLM, but can it understand correctly? So that's what is the challenge here. So the average Joe sees the ontologies, means the worldview differently. So we are going to convert those ontologies or the worldview, what he has given us, to the ontology. Then we started doing, is the ontology is going to work for us? If not, how are we going to get a kind of matching of or mapping of those ontologies, merge them, then we can get a better view of the world. That can be converted to some rules which we wanted. So that is the thing which these ontologies are going to. I'm going to give you an example of a hotel. I told you about hotel in the beginning. That hotel has assume this type of devices. As you know, there are IoTs are coming up. These are all different places, different IoTs are there. They are able to help us, to entertain us, to make us safe, and whatever is required. They were the housekeeping and manage our keys and other things. As you can see here, I have put them on a level 0, level 1, level 2, level 3, and level 4, kind of domain kind of thing. And now I'm going to show you how I'm actually going to convert the guest, whatever he said, into a graph, ontology. You can solve a graph, but it's ontology. As you can see here, see the guest regulates some of the devices for either for air purifier or the temperature or whatever it is. Also, he's going to use the safe box, that is whatever is the safe box there, to secure his belongings. Or he's going to open the key system. So opening the door, closing the door, all those things can be used by the guest. Also, there is the entertainment, TV, audio, games, and comfort device like thermostat or lighting, or even, these days there are a lot of things coming up, even including fridge or toaster or whatever it is. So that's the kind of guest is thinking. And housekeeper, they have their own view, a different view. Is that cleaning devices, what kind of thing they use, and how are they maintaining the room? That is, there is a smoke detector. They test it regularly. There is a leak. They will look for the leak detection. They will air purifier. Of course, they're going to check on this. And they are going to manage other inventory here. So you see here, these are all the control utilities, coordinates, manages, monitor. These are all the things we have to capture. And then see how we can merge a housekeeper ontology with the guest ontology or the front desk ontology. All these things can be kind of integrated or merged. How are we going to do that? So that's a kind of challenge which we have come up with, and we are able to, how similar are the two classes names. The guests are different. No two guests are same. The housekeepers, no two housekeepers are same. So all these things are keep changing. How are you going to manage this one? How are you going to merge their whatever they're saying, so that that can be kind of fed to the devices which you want to do that. So we have fission maps. We have level 1, level 0. As you can see here, the people who are, that's kind of here is the guest. What do they see here? The door locking systems, the air purifiers, or room security devices. All these things you can see here. And the same thing what happens to the union of two ontologies. You can see here how you can actually merge them. So basically, this is kind of algebraic rules which we convert in whatever they're talking about. And these rules are merged. And finally, you can see here, when they merge here, they have controls, sync, access, regulates, utilizes, manage, monitor. These are the things finally. That's what we are going to actually create. As you can see here, the guest ontology is something it is saying, and the properties of the housekeeper, the properties of the desk ontology, front desk. So these three are there, and maybe there are other people too. So we actually are able to merge all the three different roles that are being played. These roles are merged here. You can see here, these three are merged. And I'm not going to go through all these things, but basically it's a kind of how we derived at this one. And now we merged two of them. You can see here, this housekeeper and guest that are merged a little bit here. And this is going to kind of make the controls here, as you see here, the controls sync, access, regulate, these are all going to be similar. And these are all different devices managed by these people. And now the next step is we're actually going to merge all the three. How does it look like? So we have a lot of mathematical things we have derived, including a lot of theorems. How are we going to actually do instantial mergers, also extensile mergers? That is, if we know there is a homomorphism between two of these graphs, how are you going to merge them? Then if there is a similarity there, how are you finding it out and merge them? So all these things we are able to manipulate and come up with intermediate rules. And those intermediate rules are converted to actual vendor-specific rules. That's what we've done. So again, what we did is that we have to find out what is the hierarchy here of the merged ontologies. These ontologies structure differently on the same environment. For example, we're having everybody using similar devices, similar hotel room, but the way they actually talk is different. They are structured differently. So how are you going to find different kind of merging? Also, how are you going to find different kind of mapping, all these ontologies? And then, of course, that has to be correct, accurately described. How do we know the accuracy? Basically, how do we know the accuracy here? if we already showed it before, how we define accuracy, they have to match to our Cisco or other firewall rules. How much is the percentage that is matching? That's our bottom line. That's our ground truth. So that's what we have to do. Doesn't matter what you do, the function has to be implemented. That is, network security function has to be implemented. That's our kind of a challenge. Now, that's the last part of it, which I'm trying to go through is that how are you going to use these predicate security rules using ChatGPT agents? For example, how is that going to help the large language models? How are they going to help us? So as we know, we actually have a user, and then it will have to confirm is it enhanced, or it is a query is good, and is it actually a real user, or is just blabbering something, or he also can be a fake user, or is going to also kind of hack the network. There's also a lot of things that can happen. We need to be careful. How are you going to actually these commands can be securely and accurately and reliably converted. So we have used ontology ones. Now they're going to convert into the predicate roles. And every stage here, there need to be a feedback from the security guide, that whatever thing where or ChatGPT, whatever you're using here, there should be feedback here. There will be feedback here to the user. And also there will be feedback from the last one to this one as well. So there are several kind of nested feedback. That's what is required. So now we come to this ChatGPT. As you see here, this is a typical automated feedback control system. So we all know this is an adaptive and automated feedback control system. And we want to put ChatGPT in the loop and understand how it behaves. So what we did is actually in experiments we put human in the loop. We actually put the small systems of ChatGPT or even LLM in the loop with a larger system. How is it going to behave? Can one ChatGPT talk to the other ChatGPT? Can two ChatGPTs or the LLMs can be connected back to back? What happens? So all these things are important to understand as how an average Joe kind of English can be interpreted successfully and downloaded into the final security device. Again, you see here, this has a lot of applications. This is only the security device, and this is only the word we said about hotel or some other application. But if you look at it, it has much more wider applications because it impacts a lot of citizens. Now, you can see here, we have ontology, the domain, we have ontology rules, and then we have converted the ontology rules, and we saw the observations, and we convert that into predicate calculus. If it is correct or incorrect, it will keep on revising it this. And we also convert that rule into simple, because when you want to tell the user, the average Joe, you got to tell very simple way in English, so that ask him to revise what he's saying, or can you kind of confirm, hey, is this what you are talking about, or something else. So you have to do convert into very simple way. So that's the reason why we have used two ChatGPTs, or we can call in again another loop. And now you can see here, ChatGPTs one after other, they are all in the loop here. Again, we have touched into the human also into this loop, and we see the human, how can he kind of impact this whole decision-making process. And in order for that, what we did is that we have used some people in our lab. They used this 1,000 or whatever it is, 10,000, 100,000, these kind of responses for the data set we have got. And that is annotated or manually, and then we compared our results with ground truth, that is manually, humanly annotated ones, and see how these two chat GPTs can work back to back, and how does it kind of help to solve our problem. So the way is we did it is that we had converted the human language to a vendor specific devices, how it actually works. We believe that this has got a lot of research challenges, and research challenges are human in the loop. How are you going to adapting human reasoning to models with few shots? How are you going to do that? There is also a nesting of LLMs, small to large probably. Who and how to connect them? Then the question comes of scalability. Of course, it's a big deal. Scalability is a big deal. And because we're going to ask 100 humans with 1 million of these requests to actually annotate them, this is going to be difficult. So how are you going to do that? Because why? Because no two humans are the same. Their worldview, it differs. Dynamic change of, also this worldview keeps changing. The view is for today, and after 1 hour it's going to change. How are we going to cope up with this? Can these nested LLMs, can they help us? How are we going to handle this? So finally, I'm actually going to show you some of the kind of projects which we are doing in our lab, just to give you an idea. I think it's already 52 minutes, kind of 51. So I want to just tell about AI for blockchain for AI. So this one, blockchain for AI, we just got last year a Best Paper Award. We are actually able to implement several AI algorithms inside the blockchain. As you know, almost all the blockchain, the languages, they don't implement floating point. And that's a big problem because they're all tuned to a not an integer, not floating point. And we can see here how are you going to interwork the cryptocurrencies, or how are you doing the memoryless trust? Everybody talks about zero knowledge, but I think the more challenge is how are you going to have a memoryless trust? And we have also one student working on quantum for a paradigm change. Then one of the students working on avatars, and I think mobile avatars for citizens, and cyber CPR is more about next generation 911. So with this, I think thank you very much, Dr. Prakash, and giving the opportunity to present our work. And I'm hoping some more collaboration around all these universities. Thank you.
Thank you, Dr. Ram, for taking the time to go through. I think Jameson now can populate the questions which we receive. But I think maybe, I'll start with a couple of questions. It's very interesting and fascinating. You already have listed all kinds of, what everybody's, looking at future topics in research area. You mentioned that, no two humans are same, but we are talking about deploying, LLMs talking to each other, when we have issues with humans in the loop itself, and when we design next generations, whatever the AI-based systems is, how are you seeing these inconsistencies in the ontology structures when LLMs are deployed? How do you ensure that inconsistencies, in the hotel example that you talked about, of course, I think, I'm just asking a very high level question, but still has something to see. How do we ensure as researchers to see what is your perspective on validating LLMs, in terms of inconsistencies?
Yeah, so we found really very interesting observations. The interesting observations are that no two humans are same. So we actually put 3 of them. They actually were trying to annotate or trying to use even feed the information. And there is a lot of some disagreement between them. The reasoning between them is different. So we're trying to model reasoning further, tell that reasoning to the model. But I think there is a lot of discrepancies here, as you said. And that's one thing, big challenge we are finding it out. And the ontologies, as you said, are also different. So we are giving some few short examples. This is how it looks like, this is how it looks like, this is how it looks like. There is a lot of hallucination. And so again, we are kind of eating with that. What we found out is the basic research recently is that sometimes small scale LLMs work better than bigger scale LLMs because they're able to, I think it looks like, kind of fine tune themselves faster with a fewer examples. Again, this is just a preliminary result. That's why I didn't put it there actually. But I think there is more to be done and see how we can merge this and make LLMs understand what we want them to understand. I definitely we believe based on this research, the humans will play important role as well in human experts to actually explain to them how to change the dynamic environments, which they don't have information about this dynamic environment.
Great. We have a next question from Dr. Woodcook-Kosei. Would it be a good solution if we develop multi-agents which are based on LLMs, ontologies, and track user actions and even WAN, support them in securing the network?
Yes, correct. So actually, we are using multiple agents in another project. That project is more, how can AI help the blockchain? So as you know, the blockchain uses a consensus protocol. It's actually not really consensus. That's only 51%. That's not really kind of real consensus. So we are using multiple agents, AI agents you can call, and see how can they prove the theorems? How can they actually do this jury work? How can we do? So the multiple agents can actually help because they have to come to a consensus also. There is another parallel work also being done is more on the multi-party computing. There's another kind of different dimension. So the graphs, how they can be given to multiple people, multiple agents, how can they can collaboratively compute and judge or make decisions. So I think, yes.
Interesting. When you talked about, converting the work, what you have done in average Joe's conversations into, vendor-specific security protocols, could you talk about that, what that means in terms of, is it like you're talking about the rules and you generate rules in these, is it actually you have some, this is a test already been implemented, and have received good, in terms of, its implementation. I wonder, I didn't quite get that, even though I think I understand there is a value in that predicate solution that you talked about in converting.
Are you talking in the first one you're talking about, this or the next one? Which one?
The next
this one. The next one. This one is the one you're talking about?
Yes.
Okay. Yeah. So this one actually implemented in a very limited scale. So this is under testing. What I mean is that this is only done for given hotel scenario. So this is not done general, no. And even hotel scenario, we have some problems, as I just mentioned before. How are we going to merge? Most of the papers you can see on the merging of this ontology are in 21 and 22. So this is a kind of a new area which coming up. How are we going to merge these things? And and this is not actually implemented with the ChatGPT. However, that's what we are doing right now. That's what the current PhD doing, implementing this inside this project. Same as if you in the loop, he's using real chat GPTs, connecting one to other and coming up with all these findings. So the answer to your question is that it is not done. It is actually work in progress, in the sense now one of the PhD students concentrating on ontologies.
Very nice, very nice. Thank you. Jameson, do you see any other questions coming up?
No, you answered all of them.
Okay. While Dr. Ram is there, Dr. Ram, thank you so much for this presentation, and we can conclude this webinar. But I want to say that we are doing a cybersecurity research symposium, IEEE cybersecurity symposium in North Dakota, first time. And we've done this 3 years, but it was not IEEE. But I would encourage some papers, and I want you to review some papers, and can we count on your support for submission in October? This is a conference in October, but
okay. Yeah, I mean, definitely we will be able to help you whatever we can. The papers, we'll see that. We are continuously submitting papers for that. I don't know when is your deadline. We'll definitely.
I'll send you the website, what we have, and then you can review, and then we can continue our conversation. Yeah.
Sure.
Yeah. Thank you so much. It was nice getting to know you and your research, and I will be in touch as we work on some proposals or some other efforts that we do.
Just curious. I'm sorry asking the different question. Are you all in the what do you call CAE, in the NSA, got a CAE kind of thing?
Yes, we got the CAE-R. Yeah, we are the newly designated institution in CAE-R, and that's. I'm assuming are you also the director there, or from North Texas, right?
Yes. So the reason I'm asking you that maybe some of you will be there in the coming April, because I plan to be there because I have several presentations. So if you are any one of you there, I'm glad to talk to you.
Sure. They sent me something for NICE conference to come and get that, whatever that.
That's in Dallas. Actually, that's different. That's in Dallas.
Yeah, they sent for Dallas one, but I think I'm getting to know more about this thing. Maybe I'll chat with you to see what are the opportunities that we can use this designation.
Yes, definitely, because I'm hearing a lot of good things in the sense of this year. So funding from Congress.
When did UNT got this designation? Long time ago?
It's almost 20 years ago.
Wow. Okay.
So we are one of the first few got in, and we just never left. So, but I'm retiring maybe sometime. I will retire one day. I don't know when it is. But then hopefully somebody could continue. Otherwise,
sure. I'll ring you and see. I want to just pull up your brain to see what. How to document what needs to be done to maintain the status and a bunch of other things. But thank you so much, Dr. Ram. I'll be in touch.
Sure, definitely. Thank you for inviting me.